All these data led us to believe that there are small, high-temperature spots within the reactor number 4. The maximal temperature we detected was 2000 degrees. Most surfaces were at a temperature no higher than 300 degrees. Lead injection could be effective in this case. After the assessment, a decision was made, and the helicopter pilots injected 2,400 tons of lead, accurately and skillfully. They injected more and more lead day by day. I was amazed at the pace and scope of the operation, and the delivery of the required materials. Taking into account the high temperature spots, we decided to also use carbonate containing rocks, dolomite in particular, with the same intent. After the dolomite compounds decomposed, to stabilize the temperature, they left behind magnesium oxide, which was a good heat conductor. Just like lead, it diffused the heat radiation zone by conducting the heat through the metal structures. However, magnesium oxide is not a metal. It decreased the oxygen concentration in the combustion zone and repressed burning. These were the reasons to inject all these metals into the destroyed reactor. Anatoly Petrovich Alexandrov advised us to start injecting clay, which could absorb the radioactive species well. By injecting clay and sand as a filter layer, we would be able to limit the outflow in case the uranium oxide pellets melt and start producing radioactive species. We would be able to contain the radioactive species, or part of them, within the reactor. At the same time, it was clear that dropping anything from a 200 meters height into the reactor number 4 was problematic. Anything heavier than 200 kilograms created a cloud of dust on impact, and the dust carried a lot of radioactive species. The particles would rise up, agglomerate, grow, and fall out next to the reactor number 4 or at the plant site. The cloud itself played a defensive part, so that small aerosol particles would not drift too far away from the plant site. Judging by the radioactive flux from the reactor number 4, its intensity and evolution, the containment measures were effective enough. A major part of the radioactivity was contained and did not spread far away, except for, say, some amount of cesium and strontium, the most low-melting compounds of the fuel. The containment measures as a whole allowed to seal the reactor number 4, create a filter layer, stop the natural course of fuel melting by initiating a lot of endothermic reactions. The measures allowed to significantly limit the radioactive species spread from the reactor number 4 to the remote zones. These were the containment measures. These decisions were made on the evening of April 26, and they were implemented from April 26 through May 2nd. In these days, they injected large amounts of materials into the reactor. After May 2nd, they paused the injections for several days. Sometime after May 9, the air monitoring discovered a flaming spot on the wall of the reactor number 4. It was either a graphite stack or a metal structure at a high temperature. They injected another 40 tons of lead into that spot. It was the last time they injected a large amount of materials into the reactor number 4. Apart from the materials intended to stabilize the temperature inside the reactor number 4 and create a filter layer, dust suppression measures were carried out. Those were suggested by Boris Veniaminovich Gidaspov, a corresponding member of the Academy of Sciences, who came to join the on-site group later, after May 10. Solutions of dust-suppressing materials were poured into plastic bags and dropped into the reactor. The bags burst on impact, covering a large surface inside the reactor with the solution, which polymerized and solidified. Materials that produced dust and could spread out were additionally covered with this filter layer. Again, these measures were conceived on the evening of April 26. They all lasted until May 12, or maybe May 15, and most of the materials were injected as I mentioned, by May 2nd. These were the containment measures. Of course, these were supported by repeatedly taking air samples to assess the intensity and evolution of the radioactive species flow from the reactor number 4. If the initial radioactivity, and I don't mean the primary radioactive cloud at the moment of explosion, but the initial stationary radioactivity value was 1000 curie per day, then say when I left Chernobyl on May 12, this value was hundreds curie per day and continued to decrease. We argued a lot on how to accurately assess these values, take the samples, carry out the measurements and calculations precisely and correctly. This alone means that none of the dosimetry measurements were high quality. I'll expand on this a bit later. I described what was done to contain the emergency and what was done after that. A more crucial part of the April 26 decision of the State Committee was the concern for the population. As soon as we decided to cool down reactor number 4, we discussed our concerns for the town of Pripyat. On the evening of April 26, the radioactivity levels were more or less acceptable. They were in the range of millirongans per hour to tens of millirongans per hour. That was unhealthy, but left some room for hesitations. In these conditions, on the one hand, we were carrying out repeated radioactivity measurements. On the other hand, the medics were handcuffed by their instructions. Evacuation could start if there was a risk of the civilian population getting 25 Röntgen equivalent men by staying for some time in this area. Evacuation was compulsory only if the dose reached 75 Röntgen equivalent men. If the radioactivity levels were between 25 and 75 rem, the local administration had the right to make a decision. Thus, we argued a lot, and I should mention that the physicists, Viktor Alexeyevich Sidorenko in particular, anticipated that the radioactivity levels will grow worse and insisted on evacuation. The medics conceded, and at 10 p.m. or 11 p.m. on April 26, Boris Yevdokimovich Sherbina decided to start compulsory evacuation. After that, the Ukraine representatives, Comrades Plush and Nikolaev, initiated the evacuation procedures for the next day. It wasn't an easy task. They had to arrange enough vehicles. Vehicles were called in from Kiev. They had to find routes to get people around, so Colonel Berdov took charge of finding the routes and letting people know they should stay inside stone buildings. I regret to say that meant the information was spread by word of mouth, going door to door, and some people were left unaware. On the morning of April 27, I saw mothers strolling with babies along the streets, children running around, an ordinary weekend life. At 11 a.m., we were told the whole town would be evacuated by 2 p.m. The vehicles were ready, the routes were set. At 2 p.m. to 2:30 p.m., almost the whole population left the town, except for a predetermined list of staff who maintained the public utilities and 13 people who maintained the station. The staff who maintained the Chernobyl nuclear power plant moved to Skazozhny summer camp, 10 kilometers away from Pripyat.